Okay, good night. So we're gonna focus on first part of electrochemistry. And so electrochemistry is the decomposition of a substance by passing an electric current through it. So this is a branch of chemistry where we involve the behavior of a substance while a current is passed through it. Okay, so this is the setup. This is a depiction of the setup. And what we would have is a cell attached to some connecting wires. The circuit will be closed as the switch is there. And then we have two rods, usually made of graphite. And then these rods will be stuck into an electrolyte. This electrolyte allows for the passing of electrons through it in the form of ions, and that completes the circuit. This basically completes the circuit. Now, what we need to recognize is the circuitry terminology. So this is called a cell. The cell is what we usually refer to as a battery, but a battery is a group of cells. But this picture is a cell. The long spoke or line is a positive terminal, and this is the negative terminal, the short side. So wherever the short side is connected to, whichever electrode is connected to the short side will be negative, and whichever is connected to the long side, which is positive, whichever electrode is connected to that will be positive. And so the positive electrode is known as the anode, and the negative one is known as the cathode. This is the electrolyte, and for the purpose of science, we're going to recognize the flow or direction of electrons based on the conventional current theory, where electrons will flow out of the positive terminal and into the negative. In actuality, we know it's the opposite way around, but for the sake of science and the way that the equations were determined, we're gonna basically use this. So a typical electrolytic cell. All right, now what we need to also note is that in an electrolyte, you're gonna have freely moving ions. You're gonna have a mixture of positive ions known as cations and a mixture of negative ions. Well, a mixture of positive and negative ions. And the positive ones are referred to as cations, while the negative ones are referred to as anions. Now, cations match the name of cathode. They will come off at the cathode. So cations are positive, and so positive ions are attracted to negative ions. So positive particles are attracted to negative particles, and vice versa. So because the cathode is negative, the cations are attracted to it. Okay, that's an easy way to remember that the cathode is negative. If the cations are positive, the cathode must be negative. Same thing here. The anions are negative, so they're going to be attracted to the anode, which is a positive electrode. So the anions are negative. So to remember the cations that are most popular, because there are more, but these are the most popular. Remember this mnemonic here for the cations. Please send Charlie's monkeys, and we don't usually say crazy zebras, but the carbon is put in place here. So those with the stars, they're not usually put in here, but I included them just because sometimes you might need a little help somewhere. So please send Charlie's monkeys, and if you want to remember, carbon is between and zebras, so crazy zebras. In tall is not usually in here as well. So tall, large, high cages, more securely guarded, and it usually stops off at guarded. So please is never there at the end, but please represents platinum. And so we have the ions there. We have potassium, sodium, calcium, magnesium, aluminum, carbon, which is not a metal, zinc, iron, tin, lead, hydrogen, which is also not a metal, copper, mercury, silver, gold, and platinum. So this is your list of cations. Now please note that the cation at the top is the most reactive, and the cation at the bottom is the least reactive. For anions now, I have here Fiona's sun never comes by in October. The most reactive being the fluoride ion, and the least reactive being the hydroxide ion. This is the fluoride ion, the sulfate anion, the nitrate anion, the chloride anion, bromide anion, and the iodide anion, and then we have the hydroxide anion. So you need to become familiar with your ions. Basically, you have to become familiar with your ions, okay? And that will make all the world of problems go away. So what I want you to also note is that, and I have the drawing right here, we have the drawing to represent the electrolytic cell. Please note that again the anode is positive, and so the negative ions will be attracted to it. And then we have here the cathode, which is negative, so the positive ions will be attracted to it, okay? And I have a little drawing here, so don't forget. Okay, and here's another thing. When it comes to electrochemistry, the ions that come out first are those that are least reactive. They're willing to give up and take on electrons easier than those at the top. Yeah. So let's see here. So moving on. Now, usually with electrochemistry, guess what? You have to learn how to write half equations. As if writing equations wasn't hard enough, you actually have to learn how to do half equations. And when I show you this, there's a trick to it. So first of all, when you're given aqueous solutions, we must remember that water is involved. And so what I would tell students is to always, even if you're not given a space, try to find a space anywhere on your test paper. And if there's an aqueous copper sulfate, blah blah blah, because it's always a story. What I want you to do is to draw a beaker and draw some type of line to represent that there's a solution in there. And I want you to write out your cations in one column and your anions in the next column. Once that is done, you look at the word aqueous. So these are keywords to look at: aqueous, molten, and concentrated. So when we say aqueous, it means there's water, a lot of water in there. When we say molten, that means that there is no water in there. It's just whatever is given. Same thing for here with aqueous. And then we have the concentrated. Concentrated means that you have more of the solute in there than the solvent. So when you want to figure out which ion to pay attention to, remember the ion that is at the bottom of the reactivity series, that's the one you want to look at too. So we're dealing with copper sulfate. So if you're dealing with copper sulfate here, right, you see that according to this, the cations, we see copper is all the way down here, and hydrogen is just below hydrogen. So therefore copper would be of interest. It's below hydrogen. And then if you look over here, we're dealing with sulfate and hydroxide ion. Sulfate is up here, hydroxide ion down here. So since it's at the bottom, that's the one we're looking at. So that's how easy it is. So you have to just look at your reactivity series. Well, you're not going to be given one, so you're going to have to remember it based on this. So with the molten now, there is nothing to look at because that's all we have in there. So these are the only ones we care about. Again, with aqueous, we look at this series here, and we see that hydrogen is here and sodium is up here. So definitely hydrogen will come up. And then with this one, we have here chloride, and hydroxide. Chloride is up here, hydroxide down here, so we're looking at this. And then for concentrated, usually what happens in this case, it affects the anion more than the cation, for some reason. So in this case, we know that potassium is at the top here, hydrogen is at the bottom, so we circle hydrogen. And because there are a lot more iodide ions than hydroxide, these are what is going to come off. You could actually do this. If I was in the lab right now, I would have done this. But I could do an electrochemistry series part 2 if I have time. Okay, so now to our half equations, which is not bad. So now we know that we're going to be dealing with copper 2+ and hydroxide minus. For this one, we're going to be dealing with Pb2+ and the bromide anion. And then we're dealing with the hydrogen here for this. And so trying to be uniform by putting positive ions at the top and negative ones at the bottom. And then we're going to deal with the hydrogen plus here and the iodide ions here. Okay, so how we do half equations? Well, this is a trick. If you see a positive sign, are you dealing with an oxidation number that has a positive in it? Just put a positive down here, and this number will come back down here to represent the number of electrons. And when you go over the electrons, when you add 2 electrons to copper, you're going to go to its neutral state. Okay? And that's that. Balance. So this will come out of solution, meaning that you can see the solution going from blue, and the specks of metal are going to come out of solution. It's really great to watch. So this is aqueous. With the hydroxide now, hydroxide is kind of different, but all you need to remember is that if you have a negative sign here, you can put a minus sign here. I'm going to put an arrow here. Usually with hydroxide ions, you're going to have water coming off. You're going to have water coming off plus oxygen. Okay? That's what you need to remember. You're going to have water coming off plus oxygen. And then we now have to balance. So if we have 3 oxygens over here, we have 2 hydrogens, we need to balance it, so I'll put a 2 in front here. And that will give us 4 hydrogens and 4 oxygens, right? Because this is 2 plus 2, that's 4. So I'll put a 4 here. Now we have to account for the amount of electrons. So we put minus, the minus is here, 4 electrons. Okay, so that is solved. But in chemistry, we don't like negative signs. So once you have a negative sign, all you have to do is add 4 electrons to this side and add 4 electrons to the next side to get rid of it on both sides. And then you rewrite the equation below as 4 OH minus gives us 2 H2O plus oxygen, that's the bubbles we're going to see, plus 4 electrons. And that's how we write this. This is aqueous. Okay? So that's what we're going to do there. Just remember that. Now, again, guess what? We have a positive sign, and the positives are really much easier to do than the negatives if you think about it. So we're going to just put an add and put 2 there, because we have 2 right there. And we're going to get lead. A solid. Well, this was liquid, sorry, because it was molten. So whenever you have them molten, you write liquid here. With bromine, put the negative here. And the thing with bromine is that bromine is a diatomic molecule. Right? All of the halogens are, when they exist in air or the atmosphere, they're all diatomic. So you would have fluorine, bromine, iodine, right? Those are the famous ones. So whenever you're writing your equation, you want to recognize that it's a diatomic molecule. It's going to be a gas. And so if you have 2 of these here, you're going to have 2 here, right? That's how you balance that. So you said 2 times this negative sign here. So please note that's how we look for all of the halogens. You will have 2, like down here. If I do this one down here, this will be 2 in front here, minus 2 electrons, because this 2 will be multiplying here. Remember the negative sign come down here, and we have here I2. But again, what I want to say is that we don't like negative signs, so we would add 2 electrons to both sides. It's just like transposition, and we rewrite the equation how it is supposed to be written to give Br2 gas. And remember, this is a liquid because it's in a molten state, plus 2 electrons. That's how we write it. Okay? And then hydrogen is not a halogen. However, it too is a diatomic molecule. So we have to account for it being a diatomic molecule. So we place it 2 in front there, and we just add 2 electrons. Why? Because we have a positive sign here, and 2 times that, we write it here. And we leave that because that's positive. And then again, we have the hydroxide ion, and because we did that earlier, it's the same. So if you get it, if you keep doing this, you'll realize all of these will always be the same. So you just have to get accustomed to doing it. So since we know that this is the same, we could just write back what it is. And we're going to get water, 2 moles of that, plus oxygen, plus the 4 electrons. And because we already worked out hydrogen, we could simply just write it back. This is a gas, and this would be aqueous. This is aqueous. This is a gas, and we would rewrite this as 2I, and this is again aqueous. Now we're adding the 2 electrons to both sides, and then we have here I2 plus 2 electrons. We have our half equations done, and we know definitely where these half equations are going to be. Now, for instance, copper 2+ is a cation, so this will happen at the cathode. Anything that has a positive oxidation state, it happens at the cathode. Cathode. And again, cathode here. So everything else that has a negative oxidation state happens at the anode. And if you look carefully, you would realize that at the cathode, you have reduction because it went from a +2 state to a 0 state, right? We went from +2 to 0, so we know at the cathode, reduction happens. So to remember that, we say red cat. Reduction at cathode. And at the anode, you would realize that we went from -1 to like a 0. 0 here, 0 here. So it went from -1 to 0. So we would have oxidized. So oxidation happens at the anode. Always. So we say maybe I should write this one, and big OX, ox. So oxidation at anode. Right? So look here again, 2 + 0. This is reduction. Minus to 0 here. This is oxidation. Because if you look at the number 9, you will see that if you go from a negative to a positive number, you're increasing, right? So for here, if you're going from +2 to 0, you're reducing. If you're going from -1 to 0, you're oxidizing, right? All right, so this is the end of the first part of electrochemistry. I hope this helped you, and Good night.